So good morning everyone. Today's class we'll discuss about what is meant by payments in blockchain and what is meant by double spending. So when you look into a blockchain system, could it be Bitcoin or Ethereum or any other blockchain system, whenever we refer the term payments, so payments actually refer to some transfer of digital assets. So here in blockchain and cryptocurrencies, the digital asset is nothing but a cryptocurrency. It could be Solano or it could be Ethereum or Bitcoin. So you name a currency and you make a transaction and payments are done using this cryptocurrency, then you say like, yes, I have transferred digital asset from one user to another user, and we are all very familiar that we are using a decentralized peer-to-peer network. Now when it comes to payments, so what are the key terms that we are supposed to know? The first is called as a digital wallet. Every user should have a digital wallet with a private public key pair, okay, to send and receive funds. The second one is transaction. I think I showed in one lecture that when you say a transaction, there should be a sender, there should be a receiver, there should be a certain amount, and of course, yes, in order to validate and verify all these three, you need to attach a digital signature also. The third one is something called as mining and validation. So whatever transactions are happening, it should be verified by the nodes. We call them as miners, we call them as validators. And once it is verified, it will be added to the blockchain. Fine. And next is something called as confirmation. So once a transaction is included in the block and that block is added to the blockchain, then the payment is considered to be confirmed. So these are the four important concepts: digital wallet, a transaction, mining or validation, and then confirmation. Fine. Now we learn the term double spending. Okay, just by the English meaning, double spending. So it is a risk that one digital currency can be spent more than once. Spending more than once. It's called as double spending. For example, we have always used these two characters, Alice and Bob. Alice is sending one Bitcoin to Bob, and at the same time, she sends the same one Bitcoin to Charlie. So without any safeguarding mechanism, both might even accept the transaction, but who has the ownership now? Fine. So this is called as double spending. So how does blockchain prevent double spending? So we just look into some techniques that I use. So the first one is distributed ledger. So all nodes will maintain the same copy of the ledger. Once a transaction is confirmed in a block, it cannot be reversed or it cannot be modified. Fine. Second, all the transactions are grouped into a block. Hope you remember that Merkle tree transaction hash, and then it's stored in the form of a Merkle tree, and that root node is saved in a block. So transactions are grouped in a block, and only one block is added at a time. And what do we use? We use some consensus algorithm, agreement algorithm, like a proof of work or proof of stake or proof of burn. So if there are any two transactions like this, which is called as a conflicting transaction, it cannot be accepted. Okay, so conflicting transactions can't be accepted. I mean, either one will be accepted, one will be rejected. So we are going to use a consensus mechanism. The third one is about transaction time stamping. So what we do, whenever we have a transaction, we'll have a timestamp. Okay, even if it is in terms of millisecond also. So each block will contain a timestamp and reference to the previous block, confirming the order of transaction, so that these coins are not used again. So preventing reuse of same coins. The fourth one is users often wait for a multiple block confirmation. For example, it is actually a 6 in Bitcoin. Okay, so we wait for a multiple block confirmation to ensure that the transaction is irreversible, and the user should know like this is not a temporarily created fourth chain. It has been added into a block and I will accept it. So these are the four methods. Fine. Using a distributed ledger, defining a consensus mechanism, transaction will be time stamped, and then don't accept a block immediately. We'll wait for 6 blocks to be added. Then I'll see that okay, this block will not have any changes, confirmations. So what are the attack vectors? So we just try to learn quickly some different types of attacks. So the first one is called as race attack, the second one is called as Finney attack, and the third one is called as 51%. What What is meant by this race attack? Two transactions with the same input sent quickly to two different nodes. Send it to Bob, send it to Charlie at the same time. Okay? How can I overcome? Now we will wait for confirmations. So this is how we can overcome. Second, Finney attack. A miner will pre-mine a block with a double spin and release it after making a purchase. So here again, we will wait for confirmation, and if there is any transaction which has not been confirmed by any other node, do not take it. The third one is called as 51% attack. A single miner or a group of miners, they will start taking control more than 50, even if it is 1% above 50, right? So it's a majority. So if it takes control and it can reverse some transaction, then that attack is called as 51%. How do you mitigate this? We can go for decentralization. Of course, yes, blockchain operates under decentralized mode. And go for high hash power, which means make that hashing problem more difficult. Okay? So in that case, you will not have more people to take the toughest problem and get the result. So these are the three attack vectors. So to summarize, payment is a digital transfer of a value via blockchain network. Double spending is spending the same digital currency more than once. How do you prevent it? Achieved via consensus, immutability and decentralization. What is meant with the term confirmation? Ensure that a transaction is securely finalized. Okay. That's all about payment and blockchain. More in the next class. Thank you.